Let's begin section 4.3, the product and quotient rules. In this video, all I'm going to do is derive and use the product rule. We'll save the quotient rule for the next video. Remember that last time we learned the power rule, which stated this, right? The derivative of x to a power is just that power times x to the power minus 1, right? Now this works for all real numbers. We showed it only for the natural numbers and 0, but we're assuming that we know it's true for all the real numbers, okay? So just a quick review. Let's find the derivatives of each of these functions. Remember, the derivative of y is given by dy over dx. This is going to equal negative 21, x to the 6th. I guess it's actually plus 2x to the negative 3. Next up, we have dy over dx equals negative root 7 over x squared. If you're wondering how I got that, note that y can be rewritten as root 7 x to the negative 1. And so you can rewrite dy over dx as negative root 7 x to the negative 2, which is the same as negative root 7 over x squared. F of t, just note that you can rewrite f of t as root 5 t to the 99th plus 7t to the negative 1 half. So f prime of t is given by 99 root 5 t to the 98, and then this will be minus 7 halves t to the negative 3 halves, or if you'd prefer, you can write this as, put the square root of t cubed down there. There you go. Okay. You have that. Do you remember the derivative of e to the x? Nicest derivative possible. Here we go. All right, so I want you to pause the video. I want you to try to do this. Find the derivative of 5x cubed times negative 2x to the negative 6. Let's do it. If you did the following, if you said, okay, f prime of x is going to equal, well, the derivative of 5x cubed, which we know is 15x squared, times the derivative of negative 2x to the negative 6, which is 12x to the negative 7, which I guess would equal 180 x to the negative 5th, or over x to the 5th, then you are wrong. Sorry, that's not how you do it. This is no good. And the reason it's no good is because we made an assumption that we shouldn't have made. We assumed that the derivative of the product was the product of the derivatives. And that might make sense because it works for sums and differences, right? We showed that last time. But it just doesn't work that way. So, fortunately, there is a way for us to take the derivative. Well, forget about the prime part right now. F of x really equals, I guess that's going to be negative 10 x to the 3 minus 6, right? You just add the exponents, and this is negative 10 x to the negative 3rd. And that means that f prime of x is going to equal 30 x to the negative 4th, which is definitely not the same as 180 over x to the 5th, right? Because this is 30 over x to the 4th. Okay? So that's how you do it. But there are some times where it might be a little impractical to simplify the product, and we just don't want to have to do that every time. So maybe it would be a good idea to learn how we can take the derivative of a product. So let's take a look at problem number 1, right? We've got a biomass of a fish population, which is defined to be what? Total mass of the population at time x. And it's given by what? The number of fish and the average mass of the fish at time x. So the number of fish is given by e to the x, right? Some sort of exponential increase, right? And the average mass of the fish is given by x to the 5th. All right. So write an expression for b of x. B of x is going to equal, just by definition, n of x times m of x, which equals e to the x times x to the 5th. Okay? And so then the question is, what's the rate of change of the biomass at time x equals 4? Okay? So this is an example where we cannot simplify this expression, right? We can't do it. We can't simplify an exponential function times a polynomial. So we need a way to find this derivative. And the way to do this is with the product rule. Yes, you need to know what I'm about to write. No, you do not need to know the proof that follows. The derivative of f times g of x is f prime of x g of x plus g prime of x f of x. Okay? So, at this point, you can skip the proof if you want. It will not be on a quiz. It will not be on a test. But I want to show you how to do it, right? So, I'm not going to skip it. So, here we go. How do we show the product rule? Well, to take the derivative of f times g of x, we are taking the limit as h approaches infinity of f of x plus h times g of x plus h minus f of x times g of x all over h. And we have to somehow get this formula from that. Really, this boils down to a bunch of symbolic manipulation along with one clever addition of the number 0. Yes, I'm serious. We add 0. We're really clever about it. So anyway, let's go ahead and add 0. Just a little bit of ingenuity, but I suppose you could say, well, look, we want to split the fraction. So what we're going to do is we're going to subtract f of x. I think we're going to do that right. I guess we'll do minus f of x g of x plus h plus f of x g of x plus h. Just going to highlight this right here. You see how this right here is 0? Okay, and then we're just going to keep what we had before. And this is all over h. Okay, why would I do that? Well, you can rearrange things pretty nicely when you do things this way. We're going to arrange these first two terms on the top together, and then these last two terms on the top together. Okay, so we're going to get f of x plus h, g of x plus h, minus f of x, g of x plus h, all over h. And then we're going to split the fraction, right? So we have plus f of x, g of x plus h, minus f of x, g of x, all over h. Okay? Next, what we're going to do is we're going to factor out that first g of h. Right? So we have limit as h approaches 0 of f of x plus h, g of x plus h. Oh, no, sorry. This is just going to be this. Factor that out. Minus f of x all over h. And then this is times g of x plus h. And then this is going to be plus. Now, we're going to factor out the f of x from this guy. All right, so we just did that. Okay? Now, one thing to keep in mind is that when we do this, as long as the limits exist, we can, limit laws say that we can put that limit as h approaches 0 sign in front of the different limits. So we have this guy, which I hope looks a little familiar right here, times the limit as h approaches 0 of g of x plus h. And then, well, f of x doesn't really need a limit. There's no h's in there. But we can also talk about the limit as h approaches 0 right here. Okay? And at this point, when we take the limit, do you see what's happening? We get f prime of x, right? This whole thing right here highlight it for you. This whole, well, let me use green. This whole thing right here is actually just f prime of x, right? This guy is still g of x plus f of x times, and then this whole thing right here is g prime of x. Right? And that's the product rule. Right? Just to rewrite it the way I had it above, f prime of x, g of x, plus g prime of x, f of x. Okay? So we're done. All right, anyway, let's go back to problem 1. What's the derivative of our biomass? Well, I guess using the product rule, and you don't have to write this every time. I'm just using it to illustrate the fact that we can use this, right? So we're going to take the derivative of x to the 5th, which we know is 5x to the 4th, leave e to the x alone, plus leave x to the 5th alone, take the derivative of e to the x, but of course e to the x is its own derivative. So we get that. So here are just some more examples. All right. This should be an f of x. Okay, find the derivative. Well, we're going to get f of x equals x to the 1/2 e to the x. Just good to keep in mind. So f prime of x is going to equal 1/2 x to the negative 1/2 e to the x plus x to the 1/2 e to the x. And if you want to rewrite this, then you can write this as e to the x over 2 root x plus root x e to the x. And there are other ways to simplify it if you want, but I'm just going to keep it this way. Right, this was e to the x plus 2x e to the x all over 2 root x, but I don't think it's worth it, right? Anyway, y is the same thing as e to the x times x to the negative 1. Actually, I'd rather put the polynomial first. dy over dx equals 1 over x squared, right? Think about why the derivative, I'll write it like this. It's going to be negative, actually it's not 1 over x squared, negative 1 over x squared, right? Negative x to the negative 2 e to the x plus x to the negative 1 e to the x, right? Because e to the x is its own derivative. And you get negative 1 over x squared e to the x plus 1 over x e to the x. Now, last but not least, look at number 3. Look at this behemoth. Right? Imagine having to simplify all that out and then take the derivative. It'd be painful. Instead, let's not simplify it. Let's just use the product rule. Take the derivative of this first term, 400 x to the 99th plus 35 x to the 6th plus 1. Remember, the derivative of x is 1, derivative of 1 is 0. And then times, keep this the same. Right? And then we're going to add, keep this the same, and then take the derivative of this guy. Remember, the derivative of square root of x is 1 over 2 root x, right? X to the 1/2, negative x, negative 1/2 x to the 1/2 x to negative 1/2, right? And I guess the plus 8 goes away, and so then we're left with that. Okay? Now, after this, we have the quotient rule. So I'm gonna end this right here.